feel the walls of the world. And he says that I am, so the mouse says that I'm the biggest thing in the universe. Okay. And so, the story has meaning in the culture that it comes from, which is the Inupiaq people of the North Shore of Alaska. But I'm going to ask you to be thinking about this meaning, because it turns out that the mouse has actually gone up and found on the inside of a upside down shoe, which is why he can touch, the sole of the shoe and the sides of the shoe, and he concludes that he's the largest person on the face of the earth. So let's see where that story takes us, but I'm going to go very quickly. Now, if I'm going too fast, someone send me a chat or something like that and let me know that, that I'm going too fast, okay? So this was where I was on the beach of the Arctic Ocean in April 2014, and I was there to study the place where global warming is happening at twice the global rate. So the warming of the temperature is warming at twice the global rate in the Arctic. And as everyone knows, just to remind you, the Arctic is a frozen ocean. So the ice that you see in the far background with the little broken up pieces, that is sea ice, and it's melting at an unprecedented rate. And that has consequences that we generally don't think about. Firstly, being where we are, which is south of northern Alaska, we don't see the connection between the melt of the ice there and what might be happening in the state of Jharkhand in India, which is probably the most climate vulnerable place in India based on certain strategies. Certain ways of drawing up human development indices. So, and it already had 100 heat waves back in 2010, which is when the state action plan was being made. So I got that statistic from there. So the connection between this and this, if there is any, what is it and why is it important? So among other things, this whole issue draws these two stories and these two locations has some lessons for us. And the lessons are the following, that the climate crisis presents a unique set of challenges. It's related to multiple other phenomena. So for instance, the native Inupiaq people of northern Alaska and the villagers of Jharkhand have not caused climate change, and yet they are the ones who are at the forefront of its impacts. But not just that, it's not just climate change that's affecting them, it's various kinds of social injustice, it's marginalization, it's colonialism. So climate change cannot be considered in isolation. And as I said, it raises questions of ethics and justice, but also we just saw that it spans vast temporal and spatial scales, and it challenges dichotomies or apparent dichotomies like human/nature, ecology/economy. And one of the things I won't have time to talk about here, I had to cut out those slides for time, is that it presents psychological barriers, and particularly for students, and particularly in the context of action and how to act without being motivated entirely by fear, because we can see in the current COVID-19 crisis what fear allows governments to do, for instance, manipulating fear, right? So we won't have time to talk too much about that, but I did want to mention it. And one of the other things I'm going to mention is also that Earth's subsystems and human systems interact complexly, and that has a specific meaning in science that leads us to understand why there can be surprises and sudden shifts and changes. So my argument is that our current paradigms are not equipped for dealing with climate change in and out of the classroom. And so over the last 8 years, I've come up with a framework. Now, this is a work in progress. I cannot say at all that I have any of the answers. I'm just exploring this whole thing. And also my expertise, I should make it very clear right from the beginning, is in an obscure area of quark physics. So I'm not a climate scientist. I think of myself as a climate science translator, but I'm also, I've had to go into forays in economics and philosophy and sociology. So part of the danger of transdisciplinary work is that you're really not an expert in anything. So I'm going to own that right up front, okay? So here are my 4 essential aspects. There's a scientific technological dimension, which is kind of obvious what that means. There's the whole transdisciplinary dimension that you cannot look at it in isolation. And there's the epistemological dimension, which I'm going to emphasize a little bit in this talk because it's really, really important. And then there's the psychosocial dimension, which I'm going to ignore a bit in this talk, although it is also really important. Threaded through all of these is the notion of climate justice. So what I do, because I teach climate science in the context of a physics classroom, typically a general physics class, both for science majors, and then there's another one that's for non-science majors, is what I've tried to do is to try to answer this question, that what are the essentials of climate science that everyone should know? And when I say everyone, I mean not just students. In order that we are inoculated against misconceptions, and in order that we have the knowledge to act in a just and democratic and effective way. But also I don't want to stop at the science, because my early experiments made me realize that not only were other disciplines entangled with this whole question, but also it was not sufficiently, it was frightening for students to learn only about the science. You had to do other things. So one of the challenges I had was to prevent piecemeal knowledge. In other words, instead of introducing, what I didn't want to do was to introduce climate science here and there where it intersected with physics topics, so that you never have a holistic picture of what the whole problem is. So what I do is I use a few contextualizing visual tools that are repeatedly used, and this is the most common one. So this picture shows you the subsystems of our planet as Earth scientists have conceptualized them. The traditional ones are life, land, air, water, and ice. And then we have this big fat bubble at the bottom, which is usually called the anthroposphere. In other words, humans. Now, this is something that geologists have talked about for some time, that human impact, as they put it, on the planet is now at a geological scale. So we need to have an entire subsystem, which we call humans, or the anthroposphere. Now, I take issue with that because I know that it's not all humans, firstly, and not all human societies, and that we have to put the blame where it belongs. So I therefore choose the term modern industrial civilization, which includes but is also broader than capitalism. And what I do is I put marginalized human groups kind of as a subset of life and the biosphere, although obviously it intersects with modern industrial civilization. And so in this picture, front and center and obvious as the nose on one's face is the justice issue. The fact that there are human societies and groups and systems that have contributed very little to the climate crisis, and yet, as students learn later, are affected the most. So there are 3 large overarching concepts, which I call meta concepts, which I use to teach climate change and to communicate climate change. And they are all in this picture, which students see every single time we talk about climate change. They have to look at this picture. And so they gradually layer and deepen their understanding of what this picture means. So the 3 major overarching concepts that I've discovered so far that are absolutely essential for anyone to know climate science, as well as other aspects of climate and how it intersects with other things, are on the next slide. So that is balance or imbalance, planetary boundaries or limits, and the idea of complexity. So they're all contained in the sentence that Earth's subsystems form a complex system interacting non-linearly with each other and with the sun to produce conditions of balance/imbalance within or outside planetary boundaries, which is the big circle. So let me just quickly check that everyone's doing okay so far. I don't see any messages on the chat features. So, okay, feel free to interrupt me if there's a problem. Okay, so what I'd like to, as I'm talking, I'd like to see, especially when we discuss things, whether you see any connection with your discipline and these large concepts that I'm going to talk about very briefly, each one of them. So here's the first one. This concept is the concept of balance or imbalance. And this has to do with the energy balance of the atmosphere. So if you want a stable temperature, basically the energy coming in into the Earth's atmosphere is basically all from the sun, and then the Earth absorbs some of it and re-radiates and then reflects some of it as well. So we talk about balance in this context. I'm not going to go into the details because of lack of time. And also, it's all connected with certain trace gases in the atmosphere, such as the most important one being carbon dioxide. So another way that we look at the idea of balance or imbalance is through the carbon cycle. So we know that carbon dioxide is a greenhouse gas and that it has the effect of trapping is not quite the right word, but essentially trapping the Earth's heat that would otherwise be re-radiated into space. And carbon dioxide is a very small percentage of the Earth's atmosphere. It's only 0.04% or so. And yet a small amount goes a really long way, because that little amount of carbon is the difference between minus 19 degrees Celsius as the Earth's global average surface temperature versus what it actually is, which is about plus 14 degrees Celsius. So it makes about a 33 degrees Celsius difference. That's 0.04%. So the carbon cycle is super important. And one of the really effective ways of illustrating it is through this bathtub or kitchen sink concept. So if you think of the bathtub as the atmosphere and the water in the bathtub as the carbon dioxide level in the atmosphere, and then if you think of the faucet or the tap as everything that adds carbon dioxide to the atmosphere, and the drain as everything that takes it away. So we have carbon sources and then we have carbon sinks. Then, using the water analogy, if your tap is delivering water to the bathtub at the same rate as the drain is pulling it out, you're going to have a constant amount of water in the bathtub. Similarly, if all the carbon sources are pushing carbon into the atmosphere at the same rate as the sinks are pulling them out, then you'll have a constant amount of carbon dioxide in the atmosphere. And since carbon dioxide is directly related to temperature through its quantum chemistry, essentially, which has been known since the 1850s, we see why and how. If I had time, if the details are fascinating, but I won't go into that. Anyway, so here's the idea of balance and imbalance. A balance here, if you want to use a technical term, is really what I'm calling a steady state. So if the carbon sources, the natural sources of carbon are things like animal respiration, our exhalations contain carbon dioxide. And then, of course, the natural sinks include all green plants, notably the ocean plankton, which actually pull down huge amounts of carbon, but of course also green trees on land. Now we're going to look at, and what I do is I use some iconic graphs that summarize what we know about climate change. I'm sure that many of you have seen this one. This shows carbon dioxide levels in the atmosphere from about 1 million years ago to around 2008 when this graph was made. And I want to point out a couple of features of this graph. One is that carbon dioxide levels go up and down. So we see two kinds of imbalance here. We see an oscillatory behavior over very long time scales of about 1 million years, ups and downs. And if we had time, we'd talk about glacial and interglacial cycles, but I'm going to put that aside for now. And then we see an imbalance that is the right-hand side of the graph shooting up almost vertically. Now that shooting up, the rise in carbon dioxide levels starts around the time of the Industrial Revolution, on 1750s onwards, when people in Europe started burning fossil fuels on a mass scale for the first time. And however, we know correlation and causation are two different things. But additionally, knowing that the quantum chemistry of the carbon dioxide molecule, we know that it traps heat. So, there are other more direct pieces of evidence that implicate human activity. And again, I use human within quotes, including burning of fossil fuels and land use changes as the culprit in current climate change. Notice that the carbon dioxide levels on this graph do not go above 300 parts per million. We are currently at around 412 parts per million in 2020. So this gives us a kind of historical perspective. And where you see balance here is if you were to expand this scale so that you could see it in tens of thousands of years, you'd see a roughly horizontal line above on the tops and bottoms of this oscillatory section. And that's where, and you would also see humans emerging around 200,000 years ago. You can't see it on this scale very well. So right about here. And then you would see, you would see flat areas in this graph, which indicate periods of stable carbon dioxide levels. And most recently, we've been in a relatively stable Holocene period where the carbon dioxide levels and the temperature have been such as to be conducive to the development of complex human civilizations. So carrying on, and I think I'm going a little too slowly, so I'll try to speed up, but please send me a chat if I'm not, if I'm going too fast. So here's this picture again. And so what we've just talked about is the question of balance and imbalance. And I generally have students talk through this picture about each meta concept. So I just want to show it to you, and I'm not going to talk about it, just show it to you to know, so that you can remember what it is. So the next large concept, which is related to the one about balance and imbalance, is the one about planetary boundaries. So if you think about it, think about any system that can go from a steady state or a state of balance to a state of imbalance, means that now it can either transition gradually and slowly, or it can transition in an abrupt way. And both have happened in the Earth's long 4.5 billion year history. But what it indicates is that there's a threshold, whether that's a broad threshold or a sharp threshold, beyond which a system, the Earth system, can go from balance to imbalance. And that reflects the notion of planetary boundaries. This research is from Stockholm Resilience Center at Stockholm University, where they've identified nine boundaries, planetary boundaries, within which is nestled humanity's safe operating zone. Now, what we mean by safe operating zone is a subject for a whole other talk. I'm not going to go into that, but simply that this picture recognizes that we have to live within certain boundaries of nature, certain cycles of nature. And this particular meta concept is important for two reasons. One is, of course, climate change and looking at carbon dioxide levels, but the other is to point out that it's not just climate change that's the problem. The problem is bigger than that. You can see that 4 of these boundaries have been violated, including climate change, and one of them is biogeochemical cycles. And you can see that the nitrogen cycle is in the red, and I'm hoping that Raghuram's going to be talking about that in the near future. So this helps us communicate the idea that we are breaking numerous boundaries, not just the climatic one, and therefore there's a problem that's deeper than climate change alone. So I'm just going to mention a couple of things about a couple of the boundaries. One is the biodiversity loss. Many people are familiar with this UN report that declared that about 1 million animal and plant species are under threat of extinction. We are going through the 6th extinction in Earth's long history. And this one is unfortunately and unambiguously due to human behavior, again, human in quotes, and that transformative changes are needed to restore and protect nature. And then the other one I want to talk about in terms of planetary boundaries is that, as many of us know, in 2009, world governments agreed that we cannot let temperatures rise beyond 2 degrees Celsius compared to pre-industrial times. Otherwise, we'll have uncontrollable and catastrophic climate change. And that temperature limit was, which is a very vague probabilistic one, was revised downwards thanks to the island nations and the African nations during the Paris talks in 2015, and that lowered the safe limit to 1.5 degrees C. Now, people have calculated how much CO2 you can emit before hitting the 2 degrees Celsius level, forget 1.5 for a moment. And it turns out that if we took all the fossil fuel reserves that we already have owned by governments and corporations and burned them, we would actually be 5 times over that limit, which was calculated in 2011 about 2 degrees C. So that tells you also that there are, and we also know that the fossil fuel companies are spending trillions of dollars trying to find new sources of oil and gas. Now that a lot of the oil fields and coal fields seem to be leveling off in terms of production or going down. So we know, of course, that 2 degrees C so-called safe limit is not safe. And then there's a very interesting UN report from 2 years ago about 1.5 degrees C. I won't go into the details. But again, we look at this diagram, which which then students can see that this big circle around this picture is represents the Earth, but it also has a metaphorical meaning. It stands for the planetary boundaries. And you can imagine that the circles inside the big circle, if they grow too large or they pull at one another, you can actually have the Earth system crossing the boundary that takes us beyond the safe operating zone for humanity, whatever that might mean. So the notion of planetary boundaries is also here. Okay, the third meta concept. This one is the notion of complexity, which is absolutely essential to understand some important features of global climate. And by the way, I should mention that my three meta concepts are motivated in part from gathering student misconceptions about climate change. And one of them is related to the fact that we are never taught in most of our college, education and so on, we are never taught about complexity, and yet complexity is a very important feature of the real world. So a complex system, I'm going to be a little abstract here for those who are not familiar. I promise you that we will go to concrete examples in a moment. But a complex system can have many interacting parts. That doesn't mean too many. You can have a complex system of just 4 interacting parts, for instance. But the point is that the interactions are really strong and non-trivial, or if you want to be technical, they're non-linear. And so they're just as important as the parts themselves. It was such a system that perhaps Aristotle was anticipating when he said way back when that the whole is greater than the sum of its parts, because we cannot describe such systems on the basis of the parts alone, which approach is, of course, called reductionism. So complex systems cannot be understood as systems by a reductionist approach. A reductionist approach will only take you part of the way. And features of complexity include interacting feedback loops, tipping points, non-simple causal links. Cause and effect are related in ways that are not necessarily obvious, which I was thinking about, by the way, in the context of the coronavirus outbreak as well, which is also, of course, related to this large crisis. Okay, so back to complex systems. Students at first find the concept a little abstract, but then once they recognize certain features of complexity, they start seeing it everywhere. So complex systems include our human physiological systems, ecosystems, human social networks, and of course the global climate system. They all interact strongly with each other, and I'll give you an example as to what that means in a moment. But some of the things we know about complex systems, even though it's a very new field, its roots go back to the 1800s, but development in the field really starts gaining ground in about the 1980s. So you can see how and why we might be really unprepared for complex, wicked problems, because we are not taught to think complexly. So key features: complex systems often have feedback loops, both positive and negative, which I'm going to explain in a moment. I'm going to give you one example. And they can interact with each other. Simple systems also have feedback loops, but complexity it can add complexity to that. And specifically, destabilizing feedback loops in the climate system can make for sudden changes, accelerating warming. And so their behavior is often not linear. So I'll give you an example. So if you look at this slide, this shows you 2 interacting feedback loops. And the first one I met personally was when I went to Alaska in 2014, where the sea ice is melting at a rapid rate. So let's look at the ice albedo feedback, which is the left-hand side of this picture. If we have, let's say, global warming and climate change, we start with the red letters, and we have more CO2 in the atmosphere. We have the greenhouse effect, which then causes the Arctic ice cap to melt. And this leads us to remember what the ice caps do for us, and what the Himalayas do for us, and what the glaciers do for us in terms of global climate. The sun's heat and light hit the earth and are absorbed by land and water, but they are reflected with very little absorption by shiny surfaces, which is why, of course, we tend to wear white clothes in hot weather. So the polar ice caps and all the other shiny surfaces on the planet actually reflect without absorption about 30% of the sun's energy, which means they limit how much of the sun's energy is actually absorbed by the Earth's system. So you can think of them as Earth's air conditioners in one sense. Excuse me. So the melting ice cap If the Arctic ice melts, remember it's frozen ice on seawater. So when it melts, it exposes dark water to the sun's rays. And then that dark water, instead of reflecting most of the heat and light, absorbs it and re-emits it and enhances the greenhouse effect, which causes more global warming, which melts more ice, which exposes more water. And so you can see that this is what is called a positive, in the sense of additive, destabilizing feedback loop, also known as a vicious cycle. Here's another one, the Arctic drilling feedback. So oil and gas companies are really excited that the Arctic ice is melting because it's a harsh environment. It's hard to drill there. There's quite a bit of oil and natural gas on the seabed, and the seabed is shallow. So they're very excited about it. So the melting ice means greater accessibility to Arctic oil and gas. And so if they start drilling, as Russia started in 2013, for oil and natural gas, and if we continue to burn those fossil fuels, that enhances the greenhouse effect, which worsens global warming and climate change, which causes more ice to melt, which increases accessibility to oil and gas, and you get the picture. So these sort of feedback loops that are destabilizing and interactive can cause sudden changes. And in fact, can cause the entire system to tip over to a new state where, and it's something like the difference between having a body temperature of, about 99 degrees Fahrenheit, and then if you up it by 2 degrees, that's a systemic change. Your entire body changes from a state of health to a state of sickness. So even though the change is small, because it's a systemic change, it has great significance. And I'm only going to very briefly show you this slide from a very recent and very interesting paper showing the Earth system's trajectories. If we have time, we can talk about it. But here's my point about complexity and how it's hiding in this picture. See these links between all the Earth's subsystems in this picture? These are symbolic of the complex interactions between the different subsystems. And so if we only think about each system or each subsystem as a kind of mechanical part in the Earth's climate system, we are not going to understand how climate changes, because the interactions are complex. One quick example, if you look at the water circle, the hydrosphere, well, the oceans at the moment are absorbing human emissions of carbon dioxide from the atmosphere, which is why we are not as hot as we could be. So the oceans are taking in a lot of CO2, which is why they're also acidifying. And so in other words, you can think of water as the hydrosphere, as a huge carbon sink. But the fact is that if the temperature rises, the ocean can become a carbon source. It can outgas CO2 at a faster rate than it absorbs. So these are not mechanical parts, the way that parts of an old-fashioned clock might be. The roles themselves change as the interactions change. So that is a feature of a complex system. I had mentioned that there were 4 aspects of the framework that is a ongoing framework that I'm trying to develop. And throughout these, I haven't had time to illustrate how each of these actually has climate justice threaded into it. But throughout each of these circles, we talk about those things. And I won't have time to talk much about the intersection between the scientific, technological, and the transdisciplinary. So, for instance, in the classroom, we talk about alternative economic theories, we dissect capitalism and things like that. I won't have time to talk too much about that right now. And I also won't be able to talk too much about the psychosocial dimension, as I said, but I am going to talk about the epistemological dimension. I do want to mention that all of this leads us to discuss that climate change is a symptom and not the disease, and that modern industrial civilization's impact on the environment has many aspects, and climate change is only one of them, but it is an accelerator of both environmental and social crises. And we must look closely at multiple factors. We must look at systems, and I teach systems through concept mapping, which is a very interesting technique for brainstorming. Again, I don't have time to go into that, but one of the things I do want to point out, which we talk a lot about in the classroom, is that mainstream economics does not recognize planetary boundaries. In fact, it seems to be utterly ignorant of laws of nature, including the first and second laws of thermodynamics. So it's in my opinion, the worst kind of fantasy. But in any case, we talk about this in the classroom. So we also explicitly discuss climate justice, not only through the meta concepts, but also as a separate topic during a week that we reserve for a deeper study of climate change during the semester. And we look at it on the global scale according to nations. We look at it according to income level. And we talk about climate apartheid, the fact that the rich can, at least in the short term, protect themselves from the problem that they caused, whereas everyone else suffers. And we talk about inequality, and we talk about how marginalized people who have not contributed significantly to the crisis are impacted most severely by it. But also we talk about how they have invaluable insights to offer. And I'm just going to show you very briefly this slide, which is mostly from the work of Donu Roy, about the situation in India and about the Indian poor. And I just want to acknowledge at this moment how absolutely heartbreaking it is that our migrant laborers and daily wage workers are on this mass exodus from our cities. And this is something that is part of what I'm talking about. But I want to explicitly acknowledge that this trail of tears that has been caused by the system. So anyway, then I want to talk a little bit about the epistemological dimension, and I'm going to try to go a little faster. I think I'm probably going too slowly and taking too much time. But anyway, so when we look at events, like what's happening, whether it's COVID-19, whether it's climate change, we tend to, at least most people tend to think of them as separate. Or if we belong to a particular discipline, maybe we can relate things within that discipline, but we tend not to go beyond our disciplinary boundaries or beyond our academic boundaries and so on and so forth. So, but below the events are patterns of behavior, like what is the history of how are these different events connected? How do they evolve over time? And then, of course, how are the parts related? What influences these patterns through space and time? And underlying all of that is our epistemological model or mental model. What are the values and assumptions and beliefs that shape, that give rise to all of these systems? And so what I do in the classroom is that, I go into a little bit of history of science, but we also talk about what we think are the characteristics of modern industrial global civilization: short-term thinking, thinking linearly, spatially limited thinking. Your empathy, the reach of empathy is, again, very, very limited. We have social ecological hierarchies, disposable people, disposable nature, exclusively human-centered, disconnected from the rest of nature, delusions of separateness and independence from natural cycles, and insulation from consequences. Now, many of my students start by saying, this is human nature, or humans are like that. But then we know that they are, in history as well as currently, there are societies and that don't think like that. There are systems that are not based on this sort of behavior. So I go into a little bit into the history of my field, physics. And I apologize to all historians here because I do oversimplify a little bit, but in the spirit of historian of science, Steve Shapin, who says that sometimes oversimplifications are necessary as long as we admit them, of course, when we want to ask the question, how did we get here from there? So I introduce what I call the Newtonian paradigm. It's not my term exclusively, other people have used it, which is basically, it comes from not just Newtonian physics, but also from other things like colonialism, the history of clockmaking in Europe, all kinds of things like that. But it's a mechanistic view of the universe. So all the metaphors are machine-like. Everything is like a machine, from the human body to whatever. And it's reductionist. To understand something, you understand its parts. It's atomistic. Each part can be considered separately from the other. Its role is unchanging, and so on and so forth. It's deterministic. You can ensure that everything is predictable, which is why any system that's based on control, I think this is a very attractive paradigm for that, because it gives you the illusion that you can control things because things are predictable. And of course, it's impersonal. We are separate from what we observe. This is the famous science being not a biased thing kind of thing. So anyway, and I'm just going to very briefly show you this picture, which the XY axis is something that you see in some physics textbooks, which tells you how Newtonian physics actually is contextualized. And it turns out that Newtonian physics and its assumptions are actually an approximation of more accurate theories. The universe is only Newtonian, if you can say that, at a, in a limited sense at our scale. And that quantum physics and relativity, for instance, Newtonian physics can be considered an approximation of these. So why am I showing you a graph on physics? Well, I've drawn a z-axis here, and I've pointed out here that Newtonian physics actually describes best simple systems, mechanistic systems, and yet complex systems are not mechanistic. So the more complex a system, the more outside this box it is. And in fact, we can see that all our sociology, economics, literature, all of that exists not only partly within this box, but also outside it. This also helps us because one of the things I try to do with students is to make them recognize that the paradigms through which we construct reality are just that. They're paradigms, they're frameworks, and they're default unquestioned assumptions. And we start to question them. We start to see, and so for that, one of the things we do is study a couple of indigenous cultures and their struggles with environmental or development issues. And we ask where they're related and how their value systems actually are both within and outside this box, in some sense larger than what we can imagine. So for instance, one of the central questions we ask is, what is well-being? And we talk about the Dongria Kond of the Niamgiri Hills in Odisha. And recently, I haven't done this more than once. I've started to experiment with the Vikalp Sangam website to look at real-world examples for students to see how people are, working on alternative ways of conceptualizing the world and their lives and economics and all of that. And I just want to quickly mention that I'm part of a project where we are, not me personally, but other people are interviewing people on the ground to get a grounds up grassroots view of how they experience not just climate, but all the entangled other issues. So we've interviewed people in a poor village in Jharkhand and so on and so forth. So very quickly, when we start, students always want to know, and of course, everyone wants to know, what do we do? What do we do? And from the science angle, we have to restore the carbon cycle. We have to also respect the other planetary boundaries, restore the other cycles within which we have the safe operating zone for humanity. And again, for whatever that means, it means different things to different ways of thinking. But all of this involves a lot of changes. And I've listed a few of those changes here. I'm not going to go into the details, but I've been experimenting with coming up with a justice framework for evaluating solutions. And I'm going to talk very briefly about that. Does the solution align with stabilizing climate feedback loops? Does it seek to rebalance the carbon cycle and the other natural cycles? Does it respect and work within planetary boundaries? Does it take into account the complex nature of interactions between natural and human subsystems? And then let's see, just checking. Okay. So does it take into account the possibility of tipping points? I'll give you an example of this. You know that geoengineering is a big deal. Geoengineering is the large-scale tinkering with the Earth system. It's funded mostly by fossil fuel companies and large government labs like in the US. And the idea, so one of the ideas is to put sulfur dioxide particles in the upper atmosphere, which reflect sunlight and therefore cool the atmosphere. And the thing is that even from the science angle, this is a very iffy scenario because as one scientist has pointed out, those particles in the upper atmosphere could seed just the kind of stratospheric clouds that exacerbate warming. So it could actually worsen the problem because we don't understand the complexity of the system. But also, of course, it's an excuse for fossil fuel companies to just do what they're doing. And so that's a false solution. And it's very important to ask, from what paradigm does the solution arise? Is it the same old paradigm? Can we expect the same paradigm that gave rise to this problem to give us a solution? And what are the values behind it? Who benefits? So, and then, of course, very importantly, is it a just and democratic solution? Does it promote climate justice? Does it allow for participatory democracy that employs the experiences and talents of the marginalized? And so I'm playing with this notion of these three axes, and because your solution has to be just, it has to be impactful in the sense of working with the cycles that I mentioned. But it also cannot be an individual solution by itself. It has to ripple through the system to affect the system at large. So I'm going to end with this slide, which is basically that, the story of the mouse and the shoe. And, if the mouse can push the shoe over and see that the universe is larger and scarier and more fascinating and full of many more possibilities than the mouse had imagined earlier, then maybe there's some hope. So I'm going to stop there. And thank you for your attention. And I'm going to see if yeah, so I'm all set. I'm going to stop sharing. And if people want to raise topics for discussion or ask a question, please simply unmute yourself. And I think Nagraj is going to help me do the moderation, or is going to take the lead in that. Anybody? Shall I unmute everyone first?
I would suggest, Vandana, that since there are a few people, that everybody get unmuted and we can just discuss. I would suggest.
Okay, let's do that.
Yeah.
So,
unmute everybody.
Okay, I think
great. Thanks.
Well, thank you. I'm not sure I said anything that was new or useful to anyone, but hopefully we can at least stimulate a discussion.
Thank you.
Thank you. I enjoyed it. Thank you very much.
You're very welcome.
Thank you.
Thanks, Vandana. That was fascinating.
That's really good. It's dense, so I realize it's. Can you hear me at all?
Yeah, perfectly. Yeah.
Yeah.
Okay. All right. So, may I ask the question, or maybe it's other people?
Yeah, go ahead.
Begin one. Okay, I just asked broadly, but I still was trying to follow you and couldn't hear. But let me just say, is there a meta issue involved here? Because how do we really connect climate justice or justice? That's so central to your framework. But somehow, how is it really connected to your other three things? Or they say whatever, balance, imbalance.
Yeah. So that's what I wasn't able to talk about.
Vandana, just before you respond, just one second. So Vandana and I had suggested that before that of course there could be questions related Vandana to which she could respond and should respond. But in addition, if people wish to respond to other people's questions as well and have a discussion going, that will work if it does work. Is that all right?
I'm still a bit confused about. No, I know we can.
Should I just type in the questions as they come, and then we can take three at a time or something? Okay, so I'm going to type in the first one. Can you just tell me who asked the first question? Sorry.
This is Prabhu. I'm Prabhu.
Okay, Prabhu. Thank you, Prabhu.
Vandana, so I just saw one kind of simple about it, because that's something which I was thinking, and it's connected to something, because I thought even though you adopt complexity as structures, and I'm just trying to think about it, complexity is what we should know. How can we actually build in, see, one of the things you said is that, say, a simplistic model, say, Newtonian paradigm, might actually aggravate. So we should have more complex thinking. But imagine that we have actually very, very limited worldviews. Because at one point you say, like, indigenous communities have understandings which can be drawn on to develop this. But I'm still not able to understand how do we really. So does simply the old question, does everyone has to know Marxism fully before we can start a revolution? How can we with actually simplistic models of the world, which is, in fact, how most of us navigate this world. And I think everyone will try and create a world with limited amount of knowledge, but maybe internally very complex, but in a larger scheme, very limited. If we, like that mouse, if we are still inside the thing, the shoe,
yeah,
how do you really connect it with this complexity structures? I have a, and that's where the question of democracy and participatory justice, or whatever you said,
yeah,
I just needed a way to connect these two. How if we have democracy, which would mean people with very limited and conflicting understandings, and how would we draw that into the larger question? So I agree with whatever you have said, but I thought maybe you should clarify or at least show us a way to think that with this whole complexity structure, non-linear structures with say our limited, what I don't call it limited though. I don't call it limited, but let's say broadly limited only in terms of certain knowledges about how all these things are working. Yeah, that's I think connected. These two questions are connected. What I asked.
Okay,
Yeah.
okay. So let me just make sure I've got the question right. So basically, what you're saying is, how can we think about complexity and non-linearity under conditions of limited knowledge, right?
Yeah.
That was part of it.
Yeah.
Okay.
And
I'm just making a list here so that I can and
Sure,
if there's
sure.
a part of it I've missed, please feel free to type or to let me know again.
Where is that typing thing? I cannot see it though.
If you go on the lower left-hand corner of your screen, you'll see that there are two boxes and a hand. You see that?
Why is it saying I'm muted all the time? You are muted.
Oh, I can hear you and you can hear me, so just ignore that. Yeah.
Okay.
If you see those two boxes at the left-hand lower side, the box that is on the right is the chat box. If you click on it, it should open, and that will allow you or anyone to type a message. And it looks like I missed a message.
Prabhu, there's a blue box. Hello, Prabhu?
I know, but
there's a blue box at the bottom.
Sorry. Please don't waste time. I will hear what you say.
It's next to the microphone sign. So you can type into that.
You are muted. Really. Anyway, I found. Okay. Please carry on. I can hear you.
Great. Okay, so do we want to do one more question before I try to answer?
Okay, who wants to go next?
Sorry, I can't hear you. Very, very low volume. Somebody was speaking.
Yes, I can't also hear. Rajeshwari. Is that Rajeshwari?
You could also send the question on the phone on WhatsApp. I'll keep my phone.
Aha. Okay.
There are questions coming in from Raghuram and from, I think, Lavanya, just as LA.
Yeah, I see that. Yeah.
Was that Lavanya speaking earlier?
No, I just typed the question.
Yeah, I can see.
Okay.
Could you please expand on how you teach complexity?
Great questions. I'm not sure I can answer them to everyone's satisfaction, but I'll try. So, should I start with this? Should I start with these questions? And then people keep typing in.
Vandana, yeah.
Okay. So Prabhu asked about how climate justice integrates with the meta concepts. So, for instance, when we talk about balance and imbalance, and we talk about the carbon cycle, and we don't just talk, we actually play a game. I use a lot of embodied learning. But anyways, so when we do that, we ask the question, why is the carbon cycle out of balance? And we know that scientifically it's because of fossil fuels and land use changes. But then we ask, like, why, who is that, where is that impetus coming from to burn fossil fuels and to have all these land use changes? And then students start, and we do it discussion based. So students start coming up with their own ideas, and eventually, and we actually look at inequality itself right in the beginning. So, one of the first things I do, can you hear me okay?
Yes, I can.
Okay, great.
Yeah.
So one of the first things I do is, my university is a very small working class state university, but we do have our own planetarium. So what we do is we look at the Earth, the satellite pictures of the Earth, and we look at, we identify the subsystems. And then what we do is we look at the Earth at night. And we see, all the lights of the cities and whatnot. And then I ask the students, why are there some places that are in darkness? And then, they usually hypothesize that, okay, low population. Then I overlay population data on top of that map, and they see that their hypothesis is not fully correct. Because there are places with relatively high population density that don't have lighting. And then they get to, okay, the world is unequal. And they can relate it to their own lives because they have pretty difficult lives themselves. So I make it personal, and I make that aspect right there in the front. And so when we talk about balance, imbalance, we talk about who's doing what. We talk about fossil fuel companies and the disproportionate power they have. Then when we talk about planetary boundaries, we talk about who's breaking the boundaries. And so we keep going back to that circle, which I call modern industrial civilization, in each of these meta concepts. And then when we get to the idea of complexity, then again, we talk about the idea of justice and how social systems are pyramid-like in structure. And we talk about how, like, for instance, one of the things we talk about complexity. Actually, I learned this from a student who said that, who was one of the few who was not depressed after I taught my section on climate science. This was before I transitioned to trans or interdisciplinarity, when I was just teaching pure climate science in a physics class. And I asked the student why she wasn't as depressed as the others. And she said, well, you said that social systems are complex systems. So I said, yes. And she said, well, then if climate systems have destabilizing feedback loops and tipping points, then social systems must also have them, right? So I said, yes. So she said, then we just need to figure out what are the changes we need to make that will change the system towards a better state. So she was thinking complexly, and it stunned me because I hadn't thought of that. So in each of these meta concepts, we thread in these ideas of justice. So and also teaching complexity in systems. Now, the challenge is that this is a regular physics course, so I don't have a whole lot of time. So I have to. Can you all hear me? Sorry.
Yeah, I can.
No?
I can.
Okay. So how do I teach complexity? Well, I'm still exploring, and I'll tell you a few things that seem to have worked, but it's an incomplete project. One is that I start with concept mapping from day one. Concept mapping is a technique that shows the relationships between concepts, whatever the subject might be. So the first concept mapping exercise is simply to introduce yourself through a concept map. So you have to draw all the connections and everything that make you who you are, And so one is the teaching technique is itself acknowledges complexity. The other thing is that I do things like, for instance, we have a simple pendulum. There's a standard physics lab where you have a pendulum sways back and forth, and you have to figure out, the trajectory. And this is a perfect Newtonian system because it's so predictable, and it's like all about control and predictability. And then the students, I give them instructions to turn that pendulum into what is called a chaotic pendulum, which is a complex system. And it just takes the pendulum bob. You have instead of a normal metal, you have a magnet, and you have 3 or 4 magnets underneath it. And then its trajectory becomes, it's deterministic but unpredictable. And it's what is called a chaotic system. Not all complex systems are chaotic, but nevertheless, it illustrates the difference between the two and the fact that you have to think differently. You can't ask, where is the pendulum bob going to be at 0.8 seconds? You can't ask those sort of questions. Your questions and the system is telling you that you have to ask different questions. So that illustrates the dramatic difference between a simple system and a complex system in that sense. So let's see. So Raghu asked about if we can break up the complexity into smaller components for the purpose of addressing the different stakeholders. That's, I think my interpretation of your question is that I guess if you're coming into the climate issue from different angles, can you take the complex issue and break it up into components from those different angles? Well, I don't see why not, except in order to keep it complex, you have to emphasize the interactions. If it's a complex system or a complex relationship, the interactions are non-trivial. So one has to be careful to avoid the Newtonian trap of having a mechanistic way of expressing it. But I don't see why not. It's not something I would necessarily try, except I have to say, I did do some concept mapping for the case study that I talked about. I wrote a case study for Arctic climate change for undergraduate education. And we talked about how the oil industry is so important to the welfare of the Inupiaq Eskimo people on the North Shore of Alaska. And yet it's the same oil industry that is undermining the climate and also their culture. So I've concept mapped that. And we actually do look at different stakeholders there. We look at the oil companies, we look at the different opinions among the indigenous people, and we look at the large conservation groups as well. So let's see. So Vasudha asked the question, what is justice? Could you explain? I think there are people here who are better qualified to explain what justice is. I can only tell you how I bring it up in this context, which is that the people who have caused the problem are the ones who are kind of getting off almost scot-free, right? They are the ones who are able to adapt better. They are the ones with access to infrastructure. The people who have not caused the problem or not contributed significantly to it are the ones who are suffering the worst impacts. And that's unjust. So that's my very simple way of talking about justice. But then we expand it to talk about the hierarchies of power and how the climate justice is part of a much larger justice issue. And again, I'm not qualified to go too much into it. I keep reading about it to expand my knowledge. So my knowledge is still, something that I'm still developing. And I hope experts in this.
Vandana,
can I just jump in here?
Vandana, can I just ask a question, which is basically that it's linked to energy, no? I mean, what you explained earlier also, which you explained to your students, is about how much energy you consume.
Right.
Right. So, but again, how do we arrive at this kind of understanding? Individual consume different amounts of energy in India itself. We are a very unequal society, and yet when we talk about climate justice, we also talk about India as being unequal in comparison. I mean, after Sunita Narayan and etc. talked about that.
Yeah.
So I think somewhere we have to have I think all of us would be agreed about justice, but how do we sort of quantify, how do we look at the problem in terms of climate justice, in which we bring in both ecology and economy? Both have to be somewhere addressed in this whole complexity. As historians, that is what many of us are very concerned about, because there's a scale in which we don't know how to calibrate it. I mean, environmentalism of the poor tries to understand that, but at the same time, it is not adequate. It doesn't seem to be getting us anywhere either in our politics of power. So I think maybe if other people could also come
please.
into this. It would be very interesting. I enjoyed what you said, but I do think that somewhere all of us have to be talking about that, and that is probably where the movement would be leading towards, because the climate justice is probably one point from where all of us can make an entry. But how and how do we understand it is itself something, an issue. I'll stop here.
Yeah, definitely. It's part of the very new and developing pedagogy and of climate change, the epistemology of climate change itself. Like, how do we understand it? How do we make sense of it? How do we, and the notion of quantifying justice. I mean, I understand what you're saying in terms of energy use, and I'm familiar with Sunita Narayan's work on this to some extent. But again, there we are talking about the same model of development that we have in place right now. And so I think that if you view it from a different epistemological lens or lenses, then the question becomes somewhat different. And maybe that is too aspirational or too utopian. But nevertheless, I feel the urge to ask the question that way. But please, others, if you want to join in on the.
Yeah.
Just a quick response is that the Sunita Narayan frame is very much a nation-state frame, and I've always been uncomfortable with the nation-state frame. And this has been discussed for very long in the literature. That's one part.
Yeah.
And Prakash Kashwan made the presentation. He made the second of the presentations at the general thing when he spoke about justice. He brought in other elements. So one question that came up during that discussion was also how we integrate and look at other species and not focus alone on human beings alone.
Right.
And there was quite some discussion then, and I think some of us presentation had sort of focused excessively on human beings, the framework of justice, and I think one needs to integrate also what's happening with other species as well in one broader sense. Just integrate the different elements of the web, the ecosystem web.
Virus included. Virus.
Oh, definitely. Virus included.
Well,
Of course it is.
I do think.
Of course, it should be included. Yeah, it is in the ecosystem.
I would like to bring in a thread which I had talked about, I think written earlier, which is about the capitalocene versus the Anthropocene. So
Right.
in a sense, we have to include the anthropos. I mean, we have to see ourselves as part of a larger web. But also the fact is that the industrial society and industrial civilization are also the capitalocene,
Right.
which Jason Moore talks about in his web of life. So I think somewhere, if we can bring some of these debates into the Indian context and how we locate them, that might be quite useful for all of us.
Yeah. In fact, the very, I'm not a political scientist, but I know that the basic definition of capitalism, which is a process that increases capital so that you can increase capital. I mean, that's your classic destabilizing feedback loop, and so it's just. And then there are a couple of other ways that we critique it from a physics perspective, because, for instance, if you look at the idea of unlimited material growth, people are forgetting that there's such a thing as the second law of thermodynamics, which means that all processes end up generating heat. So if you have material growth without end, exponential material growth, then you're going to get the Earth at like the temperature of the sun in a very short time, actually. So it's just so bizarre that mainstream economics doesn't seem to recognize that, and we do critique capitalism. I don't call it the capitalocene, although when I've had a chance to have longer discussions with students, I do talk about Donna Haraway's Thulocene as well, which is interesting. I've read staying with the problem. The title.
No, I was thinking also in terms of how he talks about cheap nature. I mean, by cheap nature, he doesn't mean cheap in the traditional sense of the word, but how constantly we are utilizing nature, which seems to be similar to what you are saying in physics. How nature seems to be the sort of, in a sense, the object of transformation. And that in itself is something which is important, whether we call it capitalocene or whatever. Maybe that will help us to understand the underlying dynamics of this ecology, economy, and justice.
Yeah, and in traditional Newtonian science, nature is always, there's always that relationship of separation and possession in a way, and control, and the fact that we are part of nature is hugely ignored.
Yes.
So
Okay,
so yes, yeah.
just on the side, Raghu's asking those not speaking, should they mute so that those who are
Can hear.
everyone can hear better? Would that work?
Yes, it
I
always
would say,
works.
Yeah.
We
I
should
would say
mute.
that I think, from Vanna's side, why don't you just mute as you had done in the beginning, and whoever has a question can unmute and then mute themselves. That might be a better,
Okay. Okay. Should I
better.
do? Okay. If anyone has any problem unmuting, please, send a message or something like that. So, okay. So let me just make sure. I mean, we'll go back. I'm sure we'll cycle back to the justice question and all of this because it's so important. But
So,
let me.
Vandana, there are some questions on the side, and there are also some people who have not spoken at all. So those who haven't spoken, if they wish to sort of chip in, Rohit, Barbara, maybe others whom I can't see. Do you all want to go?
Well, they can't. I did mute everyone. Should I unmute them? Or, I mean, please unmute yourself.
No, they can. We can unmute and speak, so it's all right.
Okay. So no worries. So I'll tell you what. Unless did someone have a question?
May I
go
ask
ahead.
a question?
Please.
Or rather make some comments. It's Barbara. In fact, I would prefer to write them out afterwards. This was a very rich and complicated lecture. And one of the elements of complexity is how you yourself are using several systems of classification, of our natural world. You began with earth science, ice, water, air, land, life, industrial civilization. We were just discussing the latter one. And then you went on to Rockstrom, where there are 9 planetary subsystems.
Yes.
And I believe that even the 9 planetary subsystems and the concepts of the threshold are being debated.
Yes.
May I just make 2 points about those 2 systems? That
Please.
there are more classifications. We have complexity in classifications, and that is very difficult. So we have a problem of consensus about the very classifications of nature. And we also have a problem, and that problem can be moved in the direction of unification, but some people might say that was tyrannical, or moved in the direction of plurality, that is accepting that there is no one way of looking even at nature and even at science. The second point I want to make about Rockstrom and the planetary thresholds is that in Leeds University, there is a project everybody can Google called The Good Life Within Planetary Boundaries. And what that does is take the Rockstrom system and add elements of human development. So there's an image rather like a donut. It's been called a donut. On the outside are the thresholds. On the inside are a number of elements of human development.
Oh, that's right. It's Kate Rayworth's work.
The project in Leeds has disaggregated that by about 100 countries.
Yes.
And the problem is that no country has achieved a high standard of human development by these indicators within the thresholds. The best countries are Cuba and Vietnam, and they have achieved a subset of human development within the planetary thresholds. That is in a way like a Dunuroy example at a different scale. So the comments are about what we do about the complexity of classifying nature and the lack of any model at all to follow to guide us in our thought about how we achieve decent standards of human development within the planetary thresholds. Those are my first comments.
Well, thank you. They're very insightful. As to the first one, I completely agree with you. There's no one framework that is the ring to rule them all kind of thing. And in fact, I expect that from different contexts, different frameworks would arise, whether they are about climate change or complexity or nature. And in fact, when we look at the epistemological dimension and we look at a couple of tribal cultures, and again, tribal cultures are not monolithic, they are distinct cultures and all of that, but that helps us to understand how much diversity there is in the world and how you don't need, or at least I personally am more of the pluralistic sort of person, where we need to first admit that these are all these frameworks or ways of conceptualizing are one among many, and like models in science, I guess they have their particular usefulnesses, if that's a word. And for certain things, they illuminate certain things, and they don't illuminate other things as well, which is why you need multiple models for multiple contexts. So I fully agree. I fully agree with that. And in fact, I think you mentioned the donut, and I have my students watch the TED Talk on donut economics just to shake them out of this rut of thinking that, I don't know, I'm sure there are many critiques of donut economics as well, but just to get them out of the imaginative rut where they're stuck thinking that mainstream economics, capitalist economics is the only thing there is. I think part of what the Vikalp Sangam project does in its own way in the country is, and this is what Ashish Kothari and others are working on, is to document the different things that people communities in India are doing, and basically to say that this is a tapestry, this is not a one size fits all. And maybe we need a project like that, where it's a project of like epistemological maps or maps of frameworks or something like that. And as to the fact that there is no model where human development has reached any sort of level, and yet we have this violent violation of planetary boundaries. That's a terrible thing. I think that we need to. I think that perhaps that's why we are all here, like to see if we can figure a way out of. Is it? Some people have called climate and all of these wicked problems a problem of the imagination, and I truly believe that that's the case. And maybe shaking us loose from our epistemological ruts is the way to think through this and work through this. But also, we always learn by engaging with the world. So so I think that's why living with communities, doing field work with communities, being with communities, and trying to understand things from their perspective is so crucial to this whole project. So, but as a non-expert in the area, that's pretty much all I can say. So if someone else has something to add to Barbara's insightful comments, please do.
Mm-hmm.
Thank you very much.
Sorry, before that, was there anybody else?
I just wanted to say that I was concerned about the planetary boundaries thing and safe operating space thing too. So I've written a couple of questions there. So
okay,
could you repeat it, Rajeshwari, because it's kind of up in the.
Sorry, I said I had a couple of questions about planetary boundaries and our understanding of safe operating space for humanity. That's something that I find very disturbing. So. So I've typed in those questions, so we can discuss it as and when we get there.
Yeah, sure. No, that's something that I'm also very concerned about. So we actually rip it apart a little bit, but I think I don't do enough with that. So let me see if I'm missing any other previous questions, and then we can get to that. So
Raghu had spoken about complexity and how. Raghu, do you want to just repeat what you had typed up about?
Yeah, can you hear me?
Yeah.
Right. Yes.
Yeah, I was just saying that, of course, these systems are complex, and complexity is in the manner of scientific understanding. This is very important. But in terms of communicating this to the various stakeholders, whether it is the government or to the communities, one should be able to deal one aspect of it at a time. So it should be possible to break this complexity into smaller, uh, less complex modules for the purpose of engaging with people or different stakeholders. That's what I said.
Yeah,
Can I come in?
Can I? Sorry.
Yeah, somebody else wanted to go. Yeah, please.
Yes. Shall I just say what I wanted to tell Raghu about this breaking it into smaller units? I think breaking it into smaller units will make it far more intelligible to policymakers. Fine, I agree. But what is important there is then to highlight that all that smaller units are parts of relationships. That is, a smaller unit is just for illustration. That there is no way we can use the illustration to jump straight, and as we do in typical, most social sciences and even the sciences, jump from there to conclusions, unless and until we map or put this particular small bit in context, the buffers, the boundaries, the redundancy, the tipping points, the nonlinear relationships, all that together. So lay it in a context of complexity and then say, okay, this is a small illustration, a small part that I'm showing you. That seems to work with bureaucrats, I agree. But when we don't do that, when we, for the ease or convenience to make it easy for them, we present it as small bits. We've had repeated failures again with bureaucrats about rainfed agriculture. This is what happens every time we tell them about complexity. Smaller bits for stakeholders is important, but we have to present it in context of complexity.
No, I agree with that. Yeah, you have to put acknowledge the complexity in the first place, and then building the specific modules that people can address without necessarily ignoring the complexity. For example, this lockdown is a very good example of complexity. At the beginning, it was very simple, just lock up the country. And now we see all those complex interactions, cascade effects coming up one after the other.
Can I just come back on that point again, Raghu? I'm sorry, I'm just being like a dumb idiot here, but the complexity and the lockdown was never ever simple. It's because some people had the power to do it that it looked simple.
Yeah, it was presented as a simple solution.
Yes, absolutely. So as Barbara said, if we take the multiple meanings and the multiple relationships that people live with, then it would have never been a simple decision. So this is what I mean. If we ignore just the simple idea of relationships, nothing exists in isolation. That it's all related. There is no system that is given to us like a mechanical system. The example that you had, Vandana, that clearly tells us that everything works precisely as we want it within a mechanical constructed system. That's not the way the biological systems work. So none of it works like that.
But I think I don't think Raghu is saying exactly that, but I think he is saying if I can hear whatever, but maybe Vandana should get back on it. I understand that how do you teach complexity in some ways? How do you pedagogically, and is that a possible way? Precisely when it is premised on the fact that the whole is greater than the parts. Now, if you break it into parts, then do you get rid of the whole? So I think that's a problem of pedagogical problem. I think that's where Raghu was asking. I'm not sure whether that's. I think that's.
Can I come in here?
Yeah, sure.
No, so I had a couple of specifics and then a broader question about how one can adopt this frame for other disciplines, because Vandana is a physicist and she is teaching basically probably many or most of our students are physics students. And so there's a way you can adopt the science frame talking about the different aspects of the physics and the science of climate change. And then she's integrating other sort of structures and bodies of knowledge, including economics, ethics, and justice, and so on. But how would one, but let me just get to one, before I get to that question, there are a couple of specifics, Vandana, in what you just quickly say, just think about the balance and imbalance. So just one which is that the sink metaphor, that image, which
Yes,
is
yes,
the exit is not static, it's sort of changing. So what the Earth system is absorbing now is not what it was absorbing 50 years ago. So
Right, right,
that external faucet is actually a faucet that's changing in size, and we can carry on talking about that because actually there's different elements of the Earth system that are not stationary, and in fact even cycles are like multiple cycles. Which are, so actually even the input is changing. But let's sort
right.
of historically, just sort of commenting a historical thing. Typically, people do tend to uh, focus on Europe and US, understandably. But China has become a non-trivial contributor, not just in volume of per capita emissions, also historically. It's currently about 13% of all historical emissions. So it's quite large. So I just sort of bring that. I had a broader question though, which is the frame itself. I've, as given that there are people here, part of our group also present here who are teaching different disciplines, it's of great to me how one can use such an integrative frame for,
yes.
say, a teacher of economics. I would love to know, for instance, how Rohit or Ishan or Shauvik would use such an integrative frame talking to a bunch of students who are economics students, right? Or say Prabhu, say teaching a history class. I know that some of the other teachers do, and how you would then, because then you would need to have, I mean, you also have science at the foundation of the frame as a physics teacher. But what would one do, say, if one was, say, an economics teacher, for instance, an example?
Yeah, yeah. If I,
Integrative framework of addressing complexity, I think is also important. But it's of
yeah.
interest to others how.
Well, there are a couple of things, but I want to, if I may, I want to quickly comment on, the earlier discussion. I think Rajeshwari and Raghu were talking about, like if you focus on the parts, you lose the whole. And I'll relate it to what you were saying also, Naga. I think that it's partly also the way we even talk to people is part of the problem. How do you meet bureaucrats and policymakers? You meet them in a conference room. There's a separation between who you are and there's no human connection. You see what I'm saying? There's no relationship except, and so I think that even the method of conveyance and the context of the meetings and the all of that is problematic and is in a sense distancing and atomistic. And and then if you want to present something that is all about connections, then your context is one that's disconnected. So how are you going to, kind of illustrate the connections, and so if you can show parts but with interactions, which is what I said earlier, then maybe, I mean, this is something we need to experiment. Like, nobody knows how to do this, I think. I mean, at least in my limited experience, I think we are all explorers here. And in terms of this is all related to how you relate to students as well. So one of the things I've found absolutely necessary to do this effectively, and again, effectively depends, some semesters work better than others, works better with some students and so on. The only thing that's given me some confidence is the fact that larger, in my exit surveys, up to 80% or more of students have positive reactions to this whole thing, and their exam papers show that they've reached some level of understanding. But firstly, most of the experiments I've done have been in a class for non-science majors. So I've actually had the fascinating task of talking to business majors and economics majors about how capitalism is screwed up. But anyway, apart from that, though, the idea behind my giving this talk is not to say necessarily that this framework is going to, with some adaptations, work for everyone, like, say, someone from economics or history or whatever, but merely to stimulate the kind of discussion where either you come up with a framework that works for you, but what I'm really arguing for is transdisciplinarity, and to have justice and systems of power as integrated into the whole discussion, because they're not separate. So whatever way you find to do that, whether it's through adapting this framework or emerging with a framework of your own, would make would make sense. I mean, that's my aim here, is to present my experiments, always ongoing, and see if that stimulates thought, and also your feedback is also helpful to me. So and then Gosh, now it tells you I'm middle-aged because I think I forgot the last point that Naga was talking about. Naga, can you remind me? I didn't answer everything you said.
That's okay. That's okay.
Mm-hmm.
Who hasn't spoken yet? Rohit, Arun, there were other people who I can't see.
Yeah.
So-
Yeah, one thing I want to, can I just finish my thought quickly? Which is that if I'm to do an effective job with all this stuff here, I'm teaching about connections and about different epistemologies, and if I'm not modeling that in the classroom, it's not going to work. Okay, it's not coming from a real place. So what I've done is and I haven't had time to talk about this, but basically teaching my students to be empowered so that they can challenge me. If I'm going to talk about challenging authority, then they better start with me. So what I've been trying to do is do experiments in democratizing the classroom. Obviously, it's not a complete democracy because I have way too much power, right? But we make consensus decisions on certain things. We make we discuss stuff. We have difficult conversations, like after 60% of the class fails the first exam and things like that. But then I see I use embodied learning, and I mean these are names that I discovered later. But not just that, but I develop a personal relationship with every single student. You have to give the students this notion that they are important no matter what. Whether they do well or not, what their background is, none of that is important to the relationship of the teacher and student. So without the relationships themselves modeling what I'm trying to say, this stuff is just going to be more, in one ear and out the other. So that's always my attempt, and I don't think we can do it without that. So let's see who I think.
Manjeet has a question here. Manjeet.
Sorry?
Manjeet has typed a question here.
Yeah, but I think there was an earlier question from Rajeshwari that we haven't talked about yet. And also Raghu had a question, why is it also carbon-centric? Mm-hmm. So can I start with those? Yeah. And then we'll go to Manjeet's question. Okay, so Raghu, I totally agree with you that everything I've talked about is very carbon-centric. I do talk about, there are a couple of things. One is that carbon dioxide is, in a sense, the starting point for a climate conversation. Because it's so crucial to temperature and the relationship with temperature. I do talk about other greenhouse gases, and then when we talk about planetary boundaries, I do talk about the nitrogen cycle a little bit, and in fact I'm eager to learn more so that I can do a better job with that. So in other words, I start with carbon. I talk a lot about carbon, but my attempt is to relate it and broaden it beyond carbon. So, and maybe I'm not entirely succeeding in that, but
sorry, this is not about you or you.
No, I know that, but
this is about even IPCC, the UNFCCC, all the governments, UN Environment Program.
Right.
Nobody even knows, even among the government's negotiators, that there is much more to climate change than carbon dioxide. Even methane, very few people know.
Right.
So what I'm wanting to know is, because I myself got into it, this field very reluctantly, whether this carbon-centric nature of the discussion, was it something that happened by default or by design, as in you have half a dozen greenhouse gases and carbon dioxide is the most prominent of them, and you also had technologies or options for negotiation on that.
Yeah.
So you started focusing on what is considered the most negotiable and then ignore the rest, or you started converting all of them into carbon dioxide for a simple science communication. Remembering half a dozen names is more difficult, but if you convert all of them into one, it might be easier. Which of them is true, or all of them are true?
There's some truth in all of them.
Can I just come in? I'm not sure whether the IPCC focus on CO2 alone. IPCC has if you look at the larger reports, I'm sure you have, Raghu, it has a lot of stuff on methane and on nitrogen as well. And methane is getting, I think, and both nitrogen as well in the context of agriculture. That's something you know much better than me or most of us. I think is getting a lot more attention in recent times, and because of the fact that there's energy transition that's going on and a greater importance to natural gas. So I think them are certainly with a certain level of imbalance, to borrow one term, but there is greater attention maybe. But you would know more, and we'd love to.
But can I just
please?
Can I just add one thing to? I mean, I think if I've understood Raghu correctly, would it? So, for example, in Delhi before the elections, when the survey happened the Indian Express and CSTS, and when they asked what is the most important problem that you see, everybody responded overwhelmingly with pollution. Let's say if we were to ask the question, is climate change the most important problem? And half these people would not have answered the same way. So perhaps there's a point there that carbon is not something that you see, is not something that you experience directly, whereas pollution, you actually see it directly, and hence people, perhaps even if not knowing about climate change, can still react to. So I think there is a point there of going beyond carbon, even in popular discussions.
Well, I certainly. Go ahead.
Yeah, no, I agree that that's one of the issues. Also, sometimes I get the feeling that um, it's again, simplifying a complex problem. By focusing a lot on climate change, in especially European or this is a Eurocentric, topic, if you ask me. A lot of countries for which this present itself in a very much more perceptible manner, that doesn't get captured. As Rohit said, climate change manifests differently in different countries.
Yeah.
And different happenings in different countries also cause climate change. Right? In Delhi, it is or PM 2.5. It's not even so much carbon dioxide. It's actually PM 2.5.
Yeah.
More than it is nitrogen. So in somewhere else, it could be hot species disappearing, and somewhere else it could be something else. So this is one part of the problem. So what people can see and perceive, they identify more easily, and it's also true for politicians. Today, politicians in Delhi are far more sensitive to the topic of pollution than to the topic of climate change, because there is a tendency to think the climate changes much more slowly, and many governments change before climate changes, and therefore it's always the next government's problem.
Yeah.
So there is a challenge of how we present the issue, and which end of the stick you begin the discussion with.
Yeah. I mean, it's certainly a very complex and entangled issue. So, part of my at least ultimate aim is to start with the carbon story because of, like you said, it's actually simpler. I'm teaching mostly non-science majors, and even when I'm teaching physics students, I'm teaching them in a physics class, So partly it's simpler to start with carbon, but my ambition is that, if you think of the complex tangle of different kinds of cycles and so on as a ball of very mixed up yarn or wool, you're following one thread, and that thread leads you to the complexity. So that's my aim. I mean, it's not something I've really realized yet by any stretch of the imagination, but I want to follow that carbon thread and then show how it's related to other things, because you're right, the talk is very carbon centric, and what you're saying also relates to some of the problems we have with globalizing things like temperature, average global surface temperature. Actually, there is no such thing as average global surface temperature physically, right? There's temperature at different parts of the globe. And when you say that our aspirational level is 1.5 degrees C or whatever, that conceals the fact that even with 1.5 degrees C, some places are going to be hotter than is possible for humans to or agriculture to exist, and some places will be cold, but and so on. So I think what you're saying is part of a larger issue as well, and that's why I think developing a complex thinking approach is a crucial thing. But also, I should say that the whole idea of complexity, which emerges in science after Newtonian, mechanistic approaches to the universe and all of that, is itself in a way problematic, because we take the tools of Newtonian thinking, the mechanistic tools, and apply it to complexity. And I often wonder, what if we had a priori complex, if we had a complex understanding to begin with, then we would be thinking completely differently about a lot of things. And I don't know what that means as yet, but I'm throwing it out there. So
at this point, is there somebody who's not spoken who wishes to go?
Well, can I just look at Rajeshwari's question about the planetary boundaries? And if that's okay.
Yeah, that's fine, please.
Okay. So first, I have to tell you, the reason why I kept saying a safe operating space for humanity, whatever that means, is because I'm not myself comfortable with that framing. And, as Barbara said, that's not the only framing out there. It has its uses in the sense that it reminds us that we live within natural systems, and that, our survival depends on what mainstream economics calls externalities, which are actually not externalities. And so that's the most useful thing I've found about it, about the notion of planetary boundaries. In terms of the safe operating space, we do spend a little time, not as much, in interrogating what that means. Does that mean, human civilization the way it is now, with its very unequal, and with its pyramidal power structures? Does it mean, what does it mean? And so we leave it as a question. We ask the question, but I typically don't have time to think deeply about it, other than pose the notion that a safe operating space within planetary boundaries actually allows for many different kinds of human civilizations to exist. But if you can clarify what you mean in terms of the antithesis of climate justice, you said, okay, safe operating relationships for human beings in each ecosystem. I really like that. And the thing that I would want to reconcile, or I would have to figure out, is, I don't want to throw away the usefulness of the planetary boundaries concept in the sense of reminding us that we live within certain cycles of nature, and that we are subject to what happens, in the non-human world. It takes one electromagnetic pulse from the sun, and our entire technological civilization is gone. And yet we stride over the earth like a colossus, right? So if you want to elaborate on that too, or if anyone else does.
Just add, yeah, thank you. That was, I liked, when I first read it, I really liked the idea of, this entire work on planetary boundaries and so on. What I do in class is to therefore, I don't use boundaries with let's say lines and circles. I leave them at least as dotted lines, that they are, and also say that they are, one is, of course, they're usually linked, but then again, they're not linear linkages that, again, one bouncing off the other. So I give them papers about, or show them how Levin's work or somebody else's work that says, this is how a complex biological system behaves. So there's a limit to which what we can know and define as, though, of course, I also agree that they use the thresholds to say this. My worry about, well, let's say, again, pitching for safe operating space for humanity is that we then ignore precisely what you said, that live in nature. So if we within these relationships, then again, this is nothing new. Kenneth Boulding said this, 1966.
It's not. Yeah.
Yeah. Odom said this, 1950s. Yeah.
That's true.
Every economic activity is an activity about material, energy, and information flows. And Boulding even asked this question about the entropy of information. I mean, energy and matter, yes, there is entropy, but does information have entropy? And then he comes back to this point about, well, it's our political system that will not allow for this. Yeah. We have a new piece of information, you're challenging something that already exists. So if we want everything to change, or if we want to live things that are changing already because of our activities, we at least should be open to this understanding that there is really no safe operating space for humanity. It's either as as systems that make sense, like the pluriverse idea that Vikalp Sangam is promoting, right? Multiple in the world and multiple ways of dealing with the world, dealing with nature. Again, through systems that, through norms of justice, norms of time. Now, environmental activists, up zero discount rate rakh do. I mean, who gave you this 15% for net present value? Who gave you this? So many years or so much, this percentage of NPV. Yeah. So there are ways in which several people are challenging what we take as given norms in economics. I think just buying into, I mean, I'm bringing this in because this argument about safe operating space is something that I think will again build another set of walls. They do say thresholds and that the boundary will shift and so on, and I completely agree with that. But even then, the fact that these are 9 planetary boundaries, they are sacrosanct, and that we should never have agriculture is one sector that has transgressed 4 of them. We should never have done that. And this is again not for knowledge. We've done this knowing fully well that we're doing it. And again, Rockstrom and others go ahead and sustainable intensification. Yeah, and that's the answer they have. Sustainable intensification, doing more of the same in a very sustained way, but sustainable for what? And that's what I call thinking with the same paradigm that caused the problem. And I agree with you. The whole concept of safety, that's something that I have not yet experimented with in the classroom, but I've actually, my other realm is speculative fiction. I've played with that concept. I mean, I think it's actually a very dangerous thing to hold on to because, we can discuss this at another time, but because it's based on fear and because it, if safety means that we are going to have perfect, the old thinking germ-free, we know that there's no such thing now, but that was there for a long time. And you're safe from every possible, and even from death, right? I mean, there are people who are seriously thinking about prolonging human life beyond. So that notion of safety is itself problematic because you can't be part of a natural ecosystem if you valorize safety or if you foreground safety to be the most important thing. So there's a lot to take apart in there, and I really appreciate your comments. I'm going to think about that, and I'm going to see what one can do. So and I'd love to.
Manjeet had a question above. Can you scroll up and you'll see his question about just above where Prabhu says bye. Manjeet says, are you there? Or should I read it out for you?
I'm just scrolling down. Oh yeah, I see you. Sorry to keep you waiting, Manjeet. Does it interest your students to discuss complexities in social or economic systems only in the context of climate change or otherwise too? They actually do. So a lot of these students are undergraduates. Many of them are business majors or economics majors, as I mentioned earlier. They tend to start recognizing complexities less in those fields, in their own fields, than in other things like their lives, for instance. They'll say things like, I went there and this happened, and if I hadn't chosen this particular if I hadn't made this particular choice, my entire life would be different, or something like that, So they tend to, and I have to point out to them explicitly, from my limited knowledge of economic systems, that global financial systems are complex, and that in a sense, catastrophic failure is built into some of these highly networked systems and so on. But my university's economics department is very Friedman-esque, so I don't know whether it is that they push their students to a place where they can't think outside that box, unless they come to my class. But they tend not to discuss complexities that way. The only time that a student has discussed complexities in the social context has been the example I told you earlier, when a student said that, she wasn't depressed because she knew that human systems are also complex. So we have our feedback loops, we can have our tipping points. We just have to find the right parameter that, where a small change can kind of ripple through the system and have a systemic shift, And so we have a sociological tipping point that can change things in a positive direction. And so that's unfortunately not a very satisfying answer, but yeah, that's what it is. So, do you want to add anything to that, Manjit, if Manjit is still here? Or should I go to Barbara's question?
Vandana, I think it's a very big question. Yeah. It's about complexity theory and its application to the economy. And I don't really expect you to answer it, but I would love other people to respond over time. I just want, I think we've been going for 2 hours, and I think it would be for another occasion.
Well, I'll just end with I'm not qualified to answer that question, but I just want to comment on it that I agree that there's too much blanket comparison between physical systems and socio-economic ones. And, in a physical system like an ideal gas, all the molecules are equal, but that's not true of social-economic systems. So I think that it can be very dangerous to make those analogies. So maybe under some circumstances like cotton markets or stock markets, that works, but maybe under most it doesn't. So that's basically all I can say on that. But it's a fascinating question. So
yeah, it is. There was a question at the top from Lavanya. I don't know whether you answered it.
Oh, I'm sorry if I missed something.
Before you get to...
No, my question's answered. Thank you.
Oh, I did? Okay. Sorry.
There's only Rohit at the end. Rohit has a question about climate skeptics. Have you...
Okay.
Yeah, can you...
Yeah. Oh, gosh, if the science is so clear, how can there be skeptics? Well, actually, it's very interesting. According to some, papers by historians of science, there's 97% of climate scientists agree that climate change is serious and human caused. And and bye, Rajeshwari, and thank you so much. I look forward to reading your work. But anyway, so there's 3% of climate scientists who don't take it seriously, and don't think climate change is anthropogenic, and perhaps they do think it's serious. I don't know, but in any case, those 3%, apparently, many of them have contacts with their fossil fuel lobby people. And there's an amazing book called Merchants of Doubt, co-written by Naomi Oreskes, who's a historian of science at Harvard. And there's also a film with the same name on the book. And essentially, there are two things. One is that the science is very clear, but telling people the science does not convince them, because this is a question of worldviews. And we'll see in other contexts also, even with politics in India, that people don't change, people resist changing their worldviews, which is why they'll dismiss facts, they'll dismiss reality, because it threatens their worldviews. And because climate science threatens the whole capitalistic, neoliberal, American way of life, or whatever you want to call it, There's some people who just simply cannot deal with that because it threatens an entire worldview, it threatens their values. And the skeptics are, like I said, the ones who are scientists or have connections. The most notorious of them is a guy called Fred Singer, who's a physicist, who also spoke for the tobacco lobby when Big Tobacco was fighting the US government. And they have used the same playbook and the same people, in fact, to throw doubt on climate science. So the book Merchants of Doubt really does shed light on this. So if that helps. So I guess I don't want to tire people also, but this has been fantastic.
I also have another meeting I have to leave. Thanks a lot for a very good lecture.
Well, this was really great. The discussion was awesome. Thank you all for enriching my own understanding. I appreciate it.
Thanks, Vandana. That was great.
All right. And stay well, everyone. Take care.
Thank you. Thank you, Vandana. I listened very carefully. Thank you.
Well, thanks. Thanks for your attention and questions. And I'll let everyone go now. So I'm going to stop the meeting. And if there's any further comments or whatever, we can discuss over email and so on. I'm looking forward to the next lecture. All right, folks. Bye for now.
Bye.
Bye.